this video, I'll walk you through how to enable and view Google Kubernetes Engine, alternatively GKE, Control Plane Logs and use them for troubleshooting some common issues. Let's get started with a brief overview of the GKE Control Plane. A GKE cluster consists of a control plane and worker machines called nodes, which together constitute the Kubernetes cluster orchestration system. The control plane runs processes such as the Kubernetes API server, scheduler, and core resource controllers. It is responsible for scheduling and managing workloads, scaling and upgrades on the nodes, managing network and storage resources for the workloads. The control plane logs contain the logs that are emitted by the Kubernetes API server, scheduler, and core resource controllers. They are stored in cloud logging and can be accessed or queried using Log Explorer or the API. And I have great news for those of you who would like to view control plane logs and troubleshoot any relevant issues. These logs are now generally available and you can configure and access them with standard GKE control plane versions 1.22 or later. Be aware, GKE control plane logs are not available for autopilot clusters. Control plane logs can be really useful in a variety of situations, especially the following. Diagnosing ongoing incidents with the workloads or worker nodes. For example, broken webhooks or latency issues manifesting as kubectl command timeouts. Identifying potential control plane outages. For example, you are unable to schedule workloads or the cluster is inaccessible. You can configure control plane logs using the Google Cloud Console or the CLI when creating a GKE cluster or for an existing GKE cluster by editing the configuration at any time. Alright, let's now look at how to enable control plane logs when creating a new cluster. Go to the GKE clusters page in the Google Cloud Console, create a standard cluster, click the Features section, go to Operations, select API Server, Scheduler and Controller Manager components. Click OK. Next, let's enable control plane logs on an existing cluster using the gcloud CLI. Execute this command to update the cluster and enable log collection. To verify the logging is enabled, execute this command on the cluster. Go to the logging section. Success! The control plane logs are enabled. Additionally, if you are using Terraform to manage your infrastructure, the logging config block in the Terraform registry for Google Container Cluster has details to configure control plane log collection. Let's switch over to cloud logging in the Google Cloud Console and view the logs. Go to the Logs Explorer in cloud logging. In the resource type section, select Kubernetes control plane component. Optionally, to view logs from only one control plane component, use the component name selector to select only API server, scheduler or controller manager. Congratulations! You have successfully enabled and are able to view control plane logs. Now let's look at some real situations to learn how to debug a GKE cluster using control plane logs. Webhooks. You can use control plane logs to troubleshoot issues with webhooks. Let's go to the GKE cluster page in the Google Cloud Console. Oops! Looks like our cluster has node registration issues. A good place to start debugging this type of issue is the Kubernetes API server. So let's check the control plane logs. These messages indicate that the webhook is rejecting requests for the Calico node container, preventing the GKE node from becoming ready. This is a common scenario in which a misconfigured webhook may intercept calls made by critical system components operating in the kube system namespace. You can leverage these logs to identify the misbehaving webhook and then modify the webhook configuration to exclude kube system resources. You can use control plane logs to troubleshoot control plane latency issues. You can inspect the following fields in API server logs to learn more about the root cause. APF is API Priority and Fairness, a mechanism to prevent the control plane from becoming overloaded. Latency is the total time for a request to be processed by the kube API server. APF_PL is the name of the priority level for that flow schema. APF_FS is the name of the flow schema to which the request was classified. APF_ISeeds or APF_FSeeds are the parameters that show how heavy we are estimating the request is. APF_additional latency is the duration of the final stage of the execution of the request. APF_execution_time is the time for bare processing the request without any additional layers like authentication and APF. You can learn more in the official Kubernetes documentation. Finally, I'd like to share a useful tip. You can add the trace flag to the control plane logs to see a detailed breakdown of the calls, including time consumed for each call. Remember, control plane logs consume the write request per minute quota of the cloud logging API. Great! In just a few minutes, you'll learn how to configure and access control plane logs to troubleshoot your cluster. To learn more about control plane logs, see the following documentation. Thanks for watching.